Acha beta, today is 18 February 2026 and it is the first Rosa, obviously in UAE and Saudi Arab, and students are absent. Most of the students are absent, so I am recording the class. Question number one of today's class is, Sir, we are given a graph of current versus voltage. And if the graph is a straight line, it means the temperature is constant and the resistance is constant. But so the graph is not a straight line. It is a curve. And this curve is bending towards current axis. And if a curve is bending towards current axis, it means the resistance of this electrical component is decreasing. When it is bending towards current, then resistance is decreasing. And we have studied, sir, when voltage is applied, then it becomes hot. When temperature rises, then which electrical component resistance begin to decrease? So, sir, the answer is, sir, it is thermistor. It is thermistor. So this is graph of thermistor. If it is a graph of filament lamp, then it bends away from current axis. If the curve is bending towards current axis, it means the resistance is decreasing and it is a thermistor. So this circuit component is thermistor. And now the next part is very simple, which I am not solving. When the current is 4 milliampere, yes, sir, this is the current 4 milliampere. They are asking what is the resistance. Then obviously you can find out the voltage, and by dividing voltage divided by current, you can calculate resistance. So this is very simple question, so we are not solving. Acha ji, this is another question, June 2021. In this question, sir, two lamps are connected in parallel, and this is a resistance wire PQ. PQ is a resistance wire which is connected in series. So the question is, the two lamps are identical. Okay. Each lamp voltage is 3 volt. You are given each lamp voltage is 3 volts. Sir, we are given. And the current is 2 ampere. G, मैं भी बताता हूँ आपको. I think it will run hardly 30 minutes more. आपके रोजे में तो बहुत टाइम है अभी. नहीं ना, हमारे तो रोजा ही नहीं ना, हमारा तो रोजा है ही नहीं आज. कल की कल देखी जाएगी. अच्छा जी, अभी जरा देखिएगा. सर, वी आर गिवन वोल्टेज. सर, वोल्टेज इज 3 वोल्ट. Each voltage is 3 volt. Current in each is 2 ampere. Okay. The question is, what is the resistance of wire PQ? What is the resistance of wire PQ? Sir, how this question be solved? I am explaining. Actually, but our total voltage is 12 volt. Total voltage is 12 volt. You know, this voltage is shared in series. This voltage is shared in series. This total voltage 12 is divided as 3 volt, and the remaining voltage will be 9 volt. So the total will be 12 volt. So this 12 volt is shared as 3 volt and 9 volt. 3 volt across lamp and 9 volt across the wire. Number one. Number two, I am asking Rafe. Rafe, can you tell me what will be the current through PQ? Use common sense, not a difficult physics. What is the current through PQ, Rafe? 3. Okay. Navia, beta, what is the current through PQ? 2 amperes, Zabardast. Beta, Pavitra, what will be the current through PQ? Pavitra? I do not know if Pavitra is in class or not, because Pavitra is in class, but I think her microphone is not working. But Pavitra, your microphone is not working. Okay, so मतलब क्या कर ले? हाँ बोलो, वो 4 एम्पियर है यार. एक्चुअली द करंट is divided. The current coming from PQ, and this current is divided 2 ampere through this lamp, 2 ampere through this lamp. Okay, so the total current coming from PQ side is 4 ampere, and this 4 ampere current, when reaches at this junction, then this 4 ampere current is divided into two sections. Into two sections, 2 ampere through one lamp and 2 ampere through other lamp. So 2 ampere plus 2 ampere, so total current is 4 ampere. Okay, so the current through PQ, it is 4 ampere. And now I am using again Ohm's law. V is equal to IR. Sir, voltage of PQ is 9. Current of PQ is 4 ampere. And we are calculating resistance. So resistance will be 9 upon 4. Resistance will be 9 upon 4. Resistance will be 9 upon 4. Okay, so this question is completed. And now, Adapta, can you answer me in decimal? 9 upon 4 means 2.25. So this is the resistance. Ataji, now the second part is more difficult, in which another piece of wire, same metal, but the length of the wire is twice. Length is twice. As well as diameter is twice. Length is twice, diameter is twice. Then you know R is equals to length upon diameter. Diameter square. It is the original formula. Resistance is equals to length upon diameter square. In this question, sir, length is doubled, diameter is doubled, so it becomes 2 upon 4. It becomes 1 upon 2. It means this resistance will be changed by 1 upon 2. And if you calculate 1 upon 2 of 2.25, then what is the result? Jibata, what is the result? 2.25 divided by 2, it will be 1.125. So this is the answer. So remember, sir, whenever the length of the wire is doubled, the diameter of the wire is doubled, it makes resistance 1 upon 2 times. It makes resistance 1 upon 2 times the calculated resistance. Oh my god, my meeting was ended. My internet is not working. I am waiting for internet connection. As it is resumed or reconnect, then I can restart my class. I am waiting for Abdullah 4G internet. Yes, Abdullah 4G is connecting, and now it is connected. So I should restart or rejoin the same class. हाँ बेटा, आतिफ, आर यू इन क्लास? बेटा राफे, आर यू इन क्लास? ओके. अरे यार, हमारे यहाँ सोलर इतने बजे खत्म हो जाता है, और सम टाइम हम भूल जाते हैं कि सोलर को हमने कनेक्ट नहीं किया दोबारा. अच्छा खैर, आई नहीं नहीं, लाइट नहीं जाती इतने बजे. जब सूरज चला जाता है ना, तो सोलर खत्म हो जाता है. तो हमें अपने जो के इलेक्ट्रिक कंपनी, उस पर चले जाना चाहिए. तो वो सम टाइम हमारी वाइफ भूल जाती है, तो अभी ये गड़बड़ हो गई। ठीक है। अच्छा, चले चले चले। अच्छा, आई एम री एक्सप्लेनिंग दिस क्वेश्चन। द क्वेश्चन इज कि वी हैव a new piece of wire, and I should re-explain. The question is, sir, we have another piece of wire. We have another piece of wire, and its length is twice, and the diameter is twice. So you know the formula of resistance is length upon diameter square. So in this question, sir, length is twice, 2 time length. Diameter is twice 2 time diameter. So this number 2 divided by 2 square, it makes 2 upon 4. 2 upon 4 means it make 1 upon 2. It means this resistance reduced to 1 upon 2. And if you solve this number by calculator, then I know it will be 1.125, or it can be rounded up to 1.13 ohm. So these kind of question we have already solved, in which length is doubled, diameter is doubled. So when length is doubled, diameter is double, overall resistance reduced to 1 upon 2. When overall resistance reduced to 1 upon 2, then total resistance of the new wire becomes 1.13. It becomes 1.13. जी बेटा, have you noted? जी बेटा, have you noted? राफे भाई, noted? No one is responding. अबे तो रिस्पॉन्ड तो कर दो, हमें तो डर लगता है कि दोबारा इंटरनेट से नहीं चलेगा। अच्छा जी, अच्छा जी, अच्छा जी, अच्छा जी। दिस क्वेश्चन इज completed, एंड नाउ I am starting, and I have selected some questions with heading. This is a question on thermistor, then I have selected a question on diode, then I have selected a question on LED, I have selected a question on LDR, etc. Okay, so now heading wise we are solving some questions. So the next question is about thermistor. Thermistor. So the question is, this is thermostat, which we know this is a thermistor symbol, and there is a fixed resistor, okay, and this fixed resistor is connected with a lamp in parallel. So what is the question? The question is, at very low temperature, at very low temperature, thermistor resistance is much higher or greater than R. Okay, so we have noticed that its resistance is very high. And you know, if the resistance is very high, then obviously its voltage would be very high. Initially, initially, when the temperature is low, at low temperature. When the temperature is low, here voltage is high and here voltage will be low. And if the voltage is low, then obviously lamp will be switched off. Okay. So what is the question? At a very high temperature, at a very high temperature, thermistor resistance is smaller. Okay, okay. State and explain the effect on the lamp when the temperature changes from very low temperature to very high temperature. From very low temperature to very high temperature. So I think I should explain first, then I can write the statement. So the explanation is, at low temperature, it is given. Low temperature, thermistor resistance is greater. Thermistor resistance is greater, it is given, so I am not rewriting. Thermistor resistance is greater, so at low temperature, PD of thermistor और component के thermistor is very high, so lamp low PD, or we can say dim light. Dim light. Okay, when there is a low temperature, at low temperature, we are given so resistance of thermistor is high, so the voltage of thermistor will be high. So when the voltage is high of thermistor, then its voltage will be low. And if the lamp voltage is low, then it it has dim light. But when temperature changing, so I'm writing, sir, at high temperature. Conversely, I'm writing at high temperature, PD of thermistor, PD of thermistor is low, so lamp high PD, bright light, bright light. So by this explanation, now I can write the statement. The statement is lamp, dim lamp converts or changes into bright lamp. Initially, the lamp is dim, low temperature, lamp is dim. High temperature, lamp becomes bright. So how is it possible? So I have explained my answer and my explanation refer to the voltage. Voltage means PD. Voltage means PD. So my whole explanation with respect to PD means voltage. So I hope that this question is explained. And now we are solving a next question. We are solving a next question. As well as I forgot to forward this class link to another student. And now, sir, the next question is about diode. The next question is about diode. Sir, what is diode? Number one, so the symbol of diode is this. Yes, this is the symbol of diode. And you know, a diode converts AC into DC. Alternating current can be changed into direct current by diode. And now I am starting solving question. The question is, sir, we are given a graph, and this is graph of an alternating current, alternating voltage, alternating power supply. And the question is, calculate the time period of alternating current. And we are given frequency. We are given frequency, and they are asking calculate time period. You know, frequency is the reciprocal of time period. So time period is the reciprocal of frequency. Sir, frequency is 60 hertz. So if you solve 1 upon 60, then you can calculate time. So this is very simple question. I'm not asking the answer. Okay. And now we are solving the B part. B part. In B part, they're asking what is A? Sir, A is diode. A is diode. Okay. This is lamp. Okay. And now, sir, we are given number of electrons and they are asking calculate current. We are given number of electrons and they are asking calculate current. Gee, Atif, can you tell me any formula of current in which number of electrons are used? Atif bhai, equation of current in which number of electrons are involved. Okay, but in this formula there is no number of electron. Assalamu alaikum Ayan. बट अयान मैंने आपको तो टाइम क्लास का दे दिया था ना, तो उसी टाइम पे आपको मैं लिंक भेजना भूल गया, लेकिन आप तो मुझे याद दिलाते बेटा। अच्छा जी, I is equal to Q upon T. It is the basic formula of current. But in this question, in this question, I think you should memorize it. Sir, charge is equal to Ne. N for number of electrons, E for charge of one electron. So Rafi answer is right. Yes. Sir, this is charge of one electron. This is charge of one electron, and this should be multiplied with number of electrons. But in the beginning of this chapter, I explained you this formula. Charge is equal to Ne. Charge is equal to Ne. And now I am putting the values. N for number of electron. In this question, sir, number of electrons are 1.5 exponent 70. This is number of electron and it is multiplied with charge. So charge is 1.6 exponent minus 19 divided by time. Sir, you are given one time period and I did not ask you what is the result of this, but I need it now. Haji Navia, can you tell me what is 1 upon 60? 0.0175 second, and now I am using the same time here because the question is calculate current during one time period. So for one time period we have calculated time, it is 0.0175. ठीक है बेटा आयान? तो आयान, I think you know current formula is charge upon time, and charge is equals to number of electrons into E. Number of electrons are, we are given 1.5 exponent 17 electron. This is number of electron. And charge of each electron, it is 1.6 exponent minus 19. It is the value of E. So charge is equal to Ne divided by time, and then you can calculate current easily. So 0.0, Rafi, 8107. Okay. So this is the answer. Okay. And now the question is mark with an arrow labeled E the direction of electrons flow through component B. Number two, mark with an arrow labeled I the direction of conventional current in component C. But the issue is, sir, this is alternating current. When this is alternating current, you know the direction of current and direction of electron keep on reversing. Keep on reversing. The direction of flow of electron. I can tell you direction of flow of electron if, sir, it is DC. Because, sir, when the source is DC, then we can draw, sir, electron are flowing in this direction and conventional current is in this direction. But I am confused. Direction of electrons flow through component B. Acha, 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 acha. Now I have understood. The concept is very, very difficult, which I am trying to explain. Suno beta, when current flows in this direction, when current flows in this direction and the arrow of current is in the direction of diode, then this current can pass. Then the current can pass. Okay, so the direction of conventional current is this. The direction of conventional current in component C. Okay, in component C. So this is the direction of conventional current. And you know, conventional current can pass through diode if the direction of conventional current and direction of diode arrow are in the same direction. So conventional current can pass through diode and they are asking to label with I. So I am labeling with I, number one. Number two, so they are asking what will be the direction of electron flow. So remember, electron flow is always opposite to the direction of current. So this is E, and E stands for electrons flow. Electrons flow. Okay, I am repeating this sentence. I think you are, this is difficult explanation. The explanation is, consider this is positive terminal, consider this is diode, this is diode. When current flows, this is conventional current. When current direction and diode arrow direction is same, then this current can pass. This current can pass. So I am writing current can pass, and current is conventional current. Conventional current can pass. Whereas if the diode is connected in the other way means, I think it is easier to reverse the direction of battery. Yes. Now you can understand, sir, when the direction of current is this, so this current cannot pass. Current cannot pass. ठीक है, बट आयान मैं अपनी बात रिपीट कर रहा हूं, आपसे पूछूंगा आयान, गौर से सुनिएगा। सर अगर करंट की डायरेक्शन डायोड एरो के साथ हो तो ये करंट पास कर जाएगा। अगर करंट की डायरेक्शन अपोजिट टू द एरो हो तो करंट पास नहीं करेगा। तो इन सर्किट नंबर वन डायोड कैन पास करंट, इन सर्किट टू डायोड कैन नॉट पास करंट। अयान बेटा बताना किस में करंट पास करेगा और किस सर्किट में करंट पास नहीं करेगा। अयान, डायोड में से कब करंट पास करेगा कब नहीं पास करेगा, जी बोलिए। बिल्कुल सही है, इसका मतलब है आपको बात समझ में आ गई। ठीक है जनाब, एंड दिस इज द डायरेक्शन ऑफ कन्वेंशनल करंट। एंड रिमेंबर, इलेक्ट्रॉन फ्लो इज अपोजिट, ठीक है ना, इलेक्ट्रॉन फ्लो इज कंसीडर्ड अपोजिट टू द डायरेक्शन ऑफ कन्वेंशनल करंट। तो आई थिंक इट इज क्लियर नाउ। अच्छा जी, ये हमने क्वेश्चन का सी पार्ट कर लिया, एंड नाउ वी आर सॉल्विंग डी पार्ट। सर इन डी पार्ट, इन डी पार्ट, सर पहली बात तो ये कि इट इज नॉट ऑल्टरनेटिंग करंट, नाउ इट इज डीसी, now it is DC. Okay. And now the question is, sir, we are given current. Current is 0.35 ampere. Calculate power supply to the circuit. They are asking calculate power supply to the circuit. And we are given voltage of the battery as well. So now it is very simple. Power is equal to current into voltage. The current of the circuit, sir, it is 0.35. The current of the circuit, 0.35. The voltage of the circuit, 12 volt. And if you multiply these numbers, then you can calculate power. And the power is 4.2 watts. The power is 4.2 watts. So this part is very simple, but this part make confusion. Okay, again, I think we have discussed and it is clear. Acha ji, now this is diode question, and now we are solving LDR question. We are solving LDR question. Sir, what is LDR? By LDR means light dependent resistor, and the resistance of LDR is inversely proportional with brightness of light. If brightness is low, then the resistance will be high. Okay, so it is the basic concept. LDR is a light sensor, thermistor is a temperature sensor, LDR is the light sensor. And now the question is the first part of the question: what is the name of component X? Sir, component X is LDR, light dependent resistor. Okay. And now the potential difference across component Y is measured with a voltmeter. The question is draw the symbol of voltmeter across component Y. Okay, across component Y. So this is voltmeter, and remember voltmeter is always connected in parallel. Voltmeter is always connected in parallel. Voltmeter is connected in parallel. And now the battery is 12 volt. Okay, I am writing the battery is 12 volt. Component Y resistance is 400 ohm. Sorry, its resistance is 400 ohm. Acha ji, in a bright room, the resistance of X is 350. So, sir, it is 350. Sir, we are given resistances. Sir, we are given total voltage. And now they are asking calculate current in the circuit. Okay, if this is a 2 mark question, and they are asking calculate current of the circuit. Current of the circuit means they are asking total current of the circuit. And total current of the circuit will be V equal to IR. So total voltage is 12. Total voltage is 12. Total current we are calculating. And what is total resistance? So total resistance is 350 plus 400. 350 plus 400. These resistors are connected in series. 350 and 400. 350 and 400 are connected in series. So I have added them 350 plus 400. So total voltage 12, total resistance 750. So the current will be 12 upon 750. Give it an idea what is the current? 0.016 ampere. So it is the total current. This is the total current. And you know in series same current passes through each resistor. So if we have calculated total current, the same current will be passing through each resistor. Same current through X, same current through Y. And now they are asking, sir, what is the voltage of Y? What is the voltage of Y? Sir, we can calculate voltage of Y. Sir, V equal to IR. I is 0.016. R is 400. And with an idea, what is the voltage? The total, sorry, the voltage of Y is 6.4. Okay, beta. So the total voltage is 12, and out of 12, 6.4 here, and the remaining voltage will be here. So voltage is divided in series circuit. Voltage is divided in series circuit. And now the last part. In a dark room, in a dark room, the resistance of component X is very high. In a dark room, the resistance of component X is very high. Okay, LDR resistance is very high. State the effect this will have on the PD of across component Y. Sir, simple X and Y. are connected in series. X and Y are connected in series. If the resistance of X is high, if the resistance of X is high in dark room, then its voltage will be high in dark room, in dark room. And if its voltage will be high, then its voltage will be low. Because in series, if the voltage of one of them is increased, then the other one voltage will decrease. So the LDR voltage will be high, so the resistance of Y will be low. Sorry, the voltage of Y will be low. So the answer is PD of Y will be low. And in this question, they are not asking explanation. They are asking state, only state. State means to the point answer देना है, लंबी नहीं करनी, लंबी नहीं करनी. ठीक है ना? So we are given in dark room, sir, in dark room, resistance of LDR is high. If the resistance of LDR is high in dark room, then its voltage will be high. If the voltage of LDR is high, then the voltage of this will be low. Voltage of this will be low. So I have written voltage of Y will be low. And now the last. But in this question, they are asking only the state. So I have written the answer, and the answer is here in the dark room. PD across Y decrease. Across Y decrease. So which I have written. And now the B part. Suggest a practical use for component X. So sir, component X is LDR, and now I am explaining by MS. Sir, in the marking scheme we are given, sir, LDR is used as light sensor. Light sensor means it is connected in street lights, and you know street lights should be switched on at night and switch off in the daylight. So it should be, okay. So LDRs are used in automatic lamps, and this LDR controls switch on, switch off system. In daytime, it should be switch off. At night time, it should be switch on. Okay, so you should memorize this sentence. And now we are solving a question on LED. LED. LED means light emitting diode, and the symbol of LED is this. And again, remember, if this is positive terminal, you know, conventional current flows from positive terminal, and when this current uh, passes through diode, yes, it can pass. Yes, it can pass. So if the direction of conventional current is in the direction of diode, then it can pass current. Okay, but now read the question. Now read the question. The question is the normal voltage of LED is 2.1 volt. I am writing. Its normal voltage is 2.1 volt. And the normal current is 0.19 ampere. Okay, we are given each and everything. Current 0.19, voltage 2.1 volt. And now the question is the potential difference across LED is measured with a voltmeter. Draw the symbol of voltmeter. I am not connecting because we have connected in the last question. Okay, I'm not connecting. The current in the LED is measured with an ammeter. Draw the symbol of ammeter. And we did not connect ammeter in the last question, so I am connecting ammeter here. When this ammeter is connected in series, okay. And now the question, sir, what is resistance of LED? Sir, we are given voltage. Sir, we are given current. So we can calculate resistance easily. R is equal to V upon I. This is V, this is I. So this is V upon I. And then you can calculate resistance easily. So I'm not solving. I'm not solving. And now there is one more question. And this question on dangers of electricity. But the issue is I should stop my class at 6:30 because it is our Namaz-e-Maghrib time, number one. Number two, my family kept Rosa even today. So